So the lab number 10 will be very quick because we need to go home anyway because we all are tired. So I first do little introduction and then practical things. So I want to believe that you are already very much skilled in anions, cations, excitations, multiplicity. I'm skipping K points and hope that Vijay will teach all of us, although it's an important thing. Just I need to sacrifice it for the sake of time. So, if you were attending presentation by Russell, you may have got an idea how to find transition state and describe reactions in Gaussian. In the transition state search and reaction path determination, one needs to specify reactant and product. What if you do not have such luxury? If you just do blind experiment, you mix something and you do not know the reactants. You want to go wild. Then you can just put all molecules together, heat them up, and look on the molecular dynamics. The molecular dynamics that you may have experienced, force field molecular dynamics, doesn't change chemical composition because it keeps number of bonds. But if you do ab initio molecular dynamics based on VASP, if you have seen coordinate files, they never tell how many bonds between which atoms. Only positions of atoms mean something. And bond is just characterized by interatomic distance and presence of this bonding anti-bonding orbitals. So VASP gives opportunity to run molecular dynamics, which is extremely important for analysis of reactions. What is molecular dynamics? Solution of Newton's equation of motion, right? Determining trajectory, position of each ion as function of time. What if you start with optimal geometry? Everything is in a minimum of your potential energy surface. And then you allow Newton's equation of motion. Would you see any dynamics? No. Because there are no stupids to go away from a minimum. If you do not kick a body, you will not get up from the couch. Is it something very correlated with real life? So, conclusion, one needs initial momentum. What is initial momentum in real life? Ambient temperature. So nothing has zero velocity. Nothing has zero momentum. Nothing resides literally at minimum. If we elevate temperature, it means each ion has a little of momentum. And if you were attending Vijay's master defense today, you may have seen. No, it was on the closed session. I cannot disclose it. But there was nice and correct equations. I'm ready to write them down later in the class. You know, amount of thermal energy per degree of freedom. Now it's question more to physics background people.
Half kBT?
Yes, one half Boltzmann constant times temperature. Right? But temperature is kinetic energy, or whatever. Yeah, kinetic energy. So you may set up an equation. On one side you have mv squared divided by 2, or p squared over 2m. On another, 1/2 kT. Then you take the square root and you find momentum based on the value of temperature, right? So it is average value of momentum. So if you assign such momentum to each ion, then you can solve Newton's equation of motion and find trajectory, how ions are moving. Of course, we are making strongest approximation, as we always did in this class. We assume that ions are point charges. They are not wave functions. But then these point charges have velocities and move according to interatomic potentials and nuclear velocities. So if we need molecular dynamics for purposes of chemistry, we need to do two things. First, we need to set up initial velocities. We can colloquially call it heating. We need to heat, thermalize model. Second, after it has been thermalized, we can solve Newton's equation of motion. We can colloquially call it molecular dynamics. For VASP software, it is two different jobs with two different templates of in-cars. So before you set up initial momenta, there is no reason to run molecular dynamics. So we will do two jobs. First job, setting up momenta. Then we pull cont car, rename it as post car, put it in new directory, and run molecular dynamics. Clear? I will practice it for the same model, and then go around and show if you are not, if you're experiencing difficulties. So this little write-up summarizes main steps. The system is not happy with me. Oh. It will take 100 minutes. No, seconds. So what I'm going to do is to create new directory. For the, I'm starting from the same root, from the same source, from the neutral ground state. I will create it nanowire, neutral ground state, and I will call it heating. And in this directory, I will copy in-car from template, in-car for heating, which you can see in this little write-up. Aha, huh? Yes, it's ready. Okay, now I need to exit the notepad and bring it back to normal fonts. Cesium gamma make directory cesium gamma neutral heating, or just heat. Copy everything into this directory. Everything is done. Go to this directory. Copy, just in case, in-car to in-car old, just in case if there were some important records or keywords. Now copy the binary directory in car and file in car. There should be one of these files should be template for heating. Copy. In car heat, it is here. So I am copying it into this directory under the generic name in-car. Okay? So this is only a non-trivial thing. The rest is standard. Now I'm looking inside. And so we do not have spin, we do not have excitations or anions. There are several parameters. So Since we are limited in time, I put most important parameter n as w equals 10. But if you do it for research or for profit, put bigger number. So parameters: beginning temperature and end temperature. Why it is not one temperature? Why there are two? Any of you were ever exposed to fabrication of inorganic things? Programmable ovens, baking stuff. Baking not like in your stove at home, but in the lab. So sometimes you need to do thermal annealing of materials. If it is not like liquid, if it is solid phase, you deposit something on the surface and you need to anneal it. London did it.
Well, I did that with hot plate.
Hot plate.
Yeah.
But hot plate is for very stable and forgiving reactions that crystal forms anyway. But for some reactions, quick heating or cooling will break crystalline lattice. Therefore, there are programmable ovens which heat up 1 degree per hour or 1 degree per minute for overnight. Then you put there your sample, and it keeps temperature for like 24 hours, and then you can degrade it. So in order to avoid formation of defects. There is a way to model annealing here. So we'll use starting and ending temperature. Right now we put just room temperature everywhere. There are some other keywords that tell that velocities will be accumulated by modeling of contact with thermostat. We can go over keywords later, but they are already set. I agree on SMAS in a right way. So another parameter that you may look at is n block. So how this stuff works? We already set up a number of ionic steps 10, which is very small. You need to do at least 50 if you do it for profit, and better like a couple hundreds. You are bringing your system in a contact with thermostat. Some of us know principles of Brownian motion, that one bigger particle can get hit by smaller particles and therefore accumulate velocity. Same with thermostat. If you have your beaker put on a hot plate, molecules of the surface of your hot plate kick surface of a beaker, and then surface of a beaker kick a solvent molecule inside. So it kicks, communicating momentum. Good, correct. Just to have everything organized, there is a parameter telling how frequent one needs to kick. So it doesn't kick any time step. It kicks and then let it accommodate this excess of energy. Then kicks once again. So if you set up total number of steps 10 and n block equals 4, it means that system will be kicked twice. It is too far to reach statistical temperature. We are just doing an example. Okay? Yes?
If they already have a velocity in a specific direction, I assume that
if you have artificially set up velocities, you do not need this.
I mean, during the trajectory, if it's going in one direction and it hits that every 4 time steps, does it give it another random velocity, or does it?
Random.
So no matter what direction.
The procedure is velocity rescaling. So it takes all velocities, look for temperature. If it is lower than thermal, it scales everything multiplying. If it is higher, it scales down also by multiplying.
Just by a Gaussian distribution?
Later. Not yes and not no. In German language, there is a word which means neither yes nor no. That sounds like doch. So, we'll discuss later. So, you better run, and while it is running, I will tell another story, partially addressing question of Brady. Since even this quick calculation take time, we'll better run it right away. So, escape. Escape, right, quit. Run VASP. 8, bigger, my GOB. More, my job. Start. Lucky day, everything runs right away. Did any of you experience waiting in a queue?
Never.
Okay, you see, it develops electronic iterations, and now when it shows line one shorter, it goes to next step. Temperature 300, it goes develop something later. So right now, velocities of all atoms are set up to provide temperature 300. But next, you see it is 0. It just makes one step, and suddenly temperature becomes 0. But we know that kicks are set up by n block, and they are separate in time. 0, again 0 at third stage. There is a puzzle. It is very related to a question by Brady. So 4, again 0. Now, at step number 5, it will be another kick. Wait. Again, we set up 300. Setting up by a thermostat. Every atom get kicks enough to reproduce room temperature. And then we look what happens on the step number 6. See, you have temperature, but it is lower than 300. How can you explain it? How can you interpret it? Do not listen to me, just run the job. I'm just entertaining you guys. And if you are on a schedule and you need to leave, I do not blame you. So how do you interpret this? And then when you go to the next step, probably it will be smaller. No? Okay. Okay, it stabilizes, but not around our desired 300, something more. So suppose you have only one-dimensional harmonic oscillator. You are kicking ions, means you are communicating velocity, momentum. So above equilibrium, you give momentum. It means it stays at the same position, but with non-zero momentum, right? And then the particle will move according to this momentum. It will move, and hit the edge. How do you call it in classical mechanics? Turning point, right? What is kinetic energy on this diagram? It's an offset between total energy and potential. When you are coming to the turning point, kinetic energy comes to 0. Therefore, we reset it to either one or another direction. Right? But we do not know if it came to turning point or maybe we reset it at different time. And if you set momentum when it was here, it may change the momentum higher or lower and then come into different direction. But if you make statistically large amount of these kicks, one needs time for system to equilibrate, that different degrees of freedom are randomly distributed and are randomly distributed between equilibrium point and turning point, so that in average temperature is kept at some average value. So therefore you need to run this several of those kicks and block. What we did right now is insufficient. We did just 2 kicks. When you do it for homework or for your research, do maybe 30 steps at least, so that it has close to 10 kicks. And then if you watch temperature as function of time, which you can do based on this data, it's set up, then drops. Then you set up and drops. Then you set up and drops. And then if you repeat it often enough, it equilibrates near the desired value. Okay? Make sense? Yes?
So if you were to do it without doing the heating step, it would stay low?
Huh?
It would to just run the dynamics without doing the heating?
If you do not heat,
it would just stay?
It will stay at the minimum. And if you heat it once, it will be not thermalized molecular dynamics. If you intentionally create momentum for a specific atom, it will be more collision experiment. You need these models, the model that I'm showing, it is very small. If you really want to speak about statistics and thermodynamics, it should be bigger models, so molecules. So on one hand, we want to simulate something small that calculations run quick. On another hand, we want bigger molecules, that statistical average principles are better and better working. And we are finding sweet spot. Okay? So last practical step for today, because it's enough. You are sacrificing your time. I appreciate it. So, upon completion of a job, you will see that there is a development of the cont car file. So be careful, it's your most precious pressure. More cont car. So if you look on the top side of this file, it looks same as before. If you literally connect, you will see that positions of ions will be changed a little bit. But in structure, it is the same. If you scroll further, you will see that when you are done with coordinates, there is another segment of data. So 3 projections. Guess what they are? I know you don't.
Positions after.
Yes, yes. So it is projections of momentum for ion number 1, projections of momentum of ion number 2. This is stuff that WASP does naturally, and Gaussian is not very happy about. Okay? And we need it for reactions. So both positions and momenta are critically important input parameters for, yes, for molecular dynamics, for Newton's equation of motion. Okay? So we are going to run WASP once again. So I am creating a directory that I name the same way as it was before, but instead of word heat, I will call it MD, for medical doctor, of course. Then I am copying everything from here to there. Okay? Now I am going to this directory, and now I'm practicing simple but critically important procedure. Copying cont car into pos car. So this is critically important step for setting up initial conditions for dynamics, for system of differential equations, right? Okay, and as we always do, to save our time, I'm just stealing template for in-car from myself. So copy tilde binary directory in-car, and then file in-car. There should be in-car medical doctor. md period slash, and I'm calling it in-car in here. Good, done. So in this template, there is a collection of keywords that instruct VASP to solve Newton's equation of motion. These forces that are extracted from first principle density functional theory. It will allow for bond breaking and formation, for chemical reactions. Well, we need to edit the in-car a little bit. vi in-car. Specifically, I want to edit number of ionic steps. Right now, by definition, it tells 1000, and protein is an amount of size of time step in units of femtoseconds. So by definition, it's 1000 femtoseconds, which is 1 picosecond, and it is reasonable for some relatively fast reaction. Today, we do not have luxury to run it 2000 steps.
Your call will be disconnected.
That's okay. So we are going to do it maybe like 10 or 20, maybe 10, just to save time. But if you do real reactions, I know what to do. It set up automatically. So if you do real reactions, for example, you are going to do a collision experiment and you are going to set up artificially quick velocity. You can approximately count your mid-school physics, how long would it take with given velocity to reach, for molecule to reach catalyst, and approximately the same time to depart from there. And range of magnitude, if you exaggerate and give a little bit higher energy compared to thermal, like the minimum 100 femtoseconds, even for very ultra-fast reactions. So 100 steps is absolute minimum for any practical research. And if you're not satisfied with precision, you may get to smaller time step. Okay, so I'm going to change, it's just 10 steps. Right, quit, no. Right, quit, enter. And now I'm just doing run VASP, 8 processors, bigger, my job. It is already running. It's very lucky day. So, I don't know if you will have enough patience to wait until these 10 steps are done. Don't listen to me, run it. Run it on your computers. I will not make circle because it's getting too late. So, what this calculation is developing? If you're looking at me, I assume that you have already started. Okay. It does create the out car file. you already know from your optimization practice that at each ionic time step, it records energies of all orbitals, total energy, positions of all ions. And here it is extremely important. So at each time step, you need snapshot of positions of all ions. So you need to see how the shape of your molecule changes at each time step. So as soon as the molecular dynamics run will be done, we need a little tool that will help us to extract snapshots of coordinates at each time step. In fact, if you use modern software for visualization, such as VMD, you need nothing. You can use additional file called x.car, or you can read out car directly into VMD, and then just navigate by mouse, run movie, or it will start running automatically. But if you are using obsolete software, or you want to be universal, you run this command and it will parse the XYZ format information out of outcome. So we are past step 2. Okay. They are very, very close to completion. So when you apply this script, and you need to wait until the job is done, it will generate file named movie.xyz. So this file will contain a list of snapshots of molecular geometries that you can analyze by human eye if you know how to interpret atomic coordinates, or you can feed into most of molecular visualizers. As soon as you generate this movie.xyz, you are not connected to specific and non-user-friendly VASP format. So you can use it with, analyze it with any software. You can look on the, it will also save the free energy along the trajectory, so you can build the reaction path. You can extract each time snapshot and run it single point energy by another software if you do not trust VASP. But this movie.xyz is really important outcome of molecular dynamics. Well, it is first outcome. There are several other observables that one can extract from this thing. We just do not have time, evidently. Yes?
Does it store the energy in the movie.xyz
Yes.
file? It just columns? Like a fourth column?
It tells step number 1, energy this much. Coordinates. Step number 2.
So I'm trying to open the outcar with BMD and it's not working.
Braden will instruct you.
VJ can also do it.
Huh?
VJ can probably do it.
So I'm practicing questions for the last few seconds, so we are already on step 7. And did anyone got it quicker? You have it, the job completed?
How do you have it show you these steps?
Huh?
How do you have it show these steps? How do you have it print out on the terminal?
Watch.
It's doing.
Watch.
Hmm?
Watch. Watch.
Oh,
Space.
oh, okay.
And then in apostrophe.
I thought you were telling me to watch the screen, so I was just
Today I met Sam Brown,
yeah.
who defended his thesis, congratulated him, and asked, "What are you going to do next?" Asking about his postdoctoral, and he answered, "Next, I'll go to lunch."
That sounds like something Sam would say. Oh, man. Oh, was he trying to like? Yeah. Load.
Is it, I'm not getting a file called movie.
You will.
Oh,
You will. I'll show you.
okay.
Just watch.
Then I didn't get there.
Yeah. Man.
Okay, so there is a time step number 10, and you see that value of temperature is different. So it's fluctuations of temperature. And as soon as this letter R disappears, it means the job is
You
done.
also need your tone card or postcard in the same directory. Because it needs to read. Then it'll.
Thanks.
You need count card and postcard?
Or.
One or the other.
Oh.
Oh yeah, it worked.
I do tone card, but.
Yeah, I did count card.
It seems that all files are there. It just maybe delayed record. Okay, done. X dot to XYZ. Maybe I need to give the okay, more movie XYZ. Yes, it does record it. Force, nothing, energy, something.
Now, if you don't have graphics like in the 60s, how would you look at that movie?
For each ion you have
A symbol? A symbol?
Yes, sure. So you here, let me show you the command x dot to xyz5. It's just updated version 5. So just upon your molecular dynamics job is done, type this command, and then you should observe formation of file. Formation of file named movie.xyz. Okay? So you may want to download this file to local computer. Unless you are so happy to try different things without graphics. So you have MovieXYZ and you can download. Where do you want to put it? Desktop. Okay. So after it is downloaded, I am going to VMD, which is installed on this things here, and let me know if you need help. Well, not now, but generally, let me know if you need help in installing VMD on your laptops. I did try to install it on different platforms like Mac, PC, and I think I did record a YouTube video, but we can do it one-to-one. So when you do have movie.xyz can be run with different software. You're not bound with VMD, but VMD is high quality. Browse desktop MovieXYZ. Load. So, if you do not see anything, should you panic?
No,
Why?
because I have experience with VMD.
Okay. So what do you do if you do not, if you see some strange dots but do not see any? You go to representations, right? And tell that instead of lines, you can do, let's say, dynamic bonds, and distance cut off is probably something that, okay, better. Now, still, we want spheres instead of atoms. Create rep CPK. Okay, so you have 4 leads, 9 cesium, and 16 iodines.
That's what we've been calculating.
Yes, it is nanowire of lead halide perovskite. You finally see what you do.
We have.
This model right now is extremely important for Vijay because it is periodic in 1 dimension and it is very easy to analyze a k-point distribution in 1 dimension rather than 3. More logical. Just in case you do not believe it is periodic, you can put.
Check postcard.
Huh? It doesn't want to show it. Okay, wait.
Oh.
Stop. Do not move. There should be same as on your tape recorder. Triangle for play. It's not very informative, and because in 10 femtoseconds for these heavy ions you will not see much. If it would be well, if CH bond or H2 bond, it will need 20 femtoseconds for full oscillation. I think CH, like for this, it will take like 200 femtoseconds just for 1 oscillation. Therefore, it just starts to move. You do not see much. But right now we are looking not on science, but on practical aspects. How to analyze it. So, extension, visualization, movie maker. I do not guarantee that this hocus pocus will work because sometimes VMD needs additional packages installed on a computer. So, but I'll try for the first time in here. So you click Movie Maker, select directory where you want to save your movie, call it, I don't know, nanowire, and select several parameters. So you do not need rock and roll, you need trajectory. If you select rock and roll, it will just not move your model, but not move along trajectory, but rotate from different angles. If you want to specify your sponsors, presentation for general audience, of course you need to do it. Rotating molecule on big screen. So trajectory, renderer. Snapshots is the cheapest one. And format. Okay, so it needs to install this package, and then you need to give a link to this package, and then it will save the movie. So, although we do not have time to complete it right now, making movies of molecular dynamics is mandatory part of this course. There are not very many mandatory parts, most of optional. Making DOS is mandatory, and making movies is mandatory. I will try to send instructions by email. Russell will teach everyone how to do it because he has the whole week to learn it before next Thursday. But making movie based on will be mandatory part of your research projects. Whatever you research, unavoidable. Movies. Enough for today. Thank you for your patience. Do not hesitate to send emails. I will be, I hope, to be alive and lecturing tomorrow. And I plan to be in Phoenix first 3 days of next week. But I will be checking emails and try to make a quick online lecture on Tuesday and answer all questions related to preparing your presentations.
ACS is in Phoenix?
No, MRS, Materials Research Society.